Hello, welcome back. As I mentioned in the last lesson, I'm going over various aspects of differentiation I taught you. Sorry, no, I shouldn't say you, because your teachers have taught you. I taught in the previous lessons to go in a sort of a revision course. Yeah? And so I have written the question. And as I said, I'm not going to give any handouts. I've written the question. I'm going to show you how to build a mathematical model, how to do it. We will go over whatever we have done before in differentiation. And then again, I write the next question, do it again, next question, do it again. So we'll do a number of questions on various aspects of differentiation. Right. Oh, by the way, my name is Sosale Mohana. I'm a teacher of maths who taught maths for over 50 years. Mainly A-level pure maths, A-level applied maths, further pure maths and further mechanics, not further stats. Okay, so this is only to help you people revise. So let's see, remember I told you, whenever you have a verbal question, underline the information. A ladder of length A, that means the length of the ladder is A constant, is leaning against a vertical wall with its foot on a horizontal ground. Draw a diagram. So that's the ground, that's the wall, and the ladder is leaning like that. That is A. Let's call that as A. Let's call that as B. That's a right hand. Good. The ladder makes an angle alpha with, I think I forgot to mention here, downward vertical. With the downward vertical. So that angle is alpha. At a given instant, the foot of the ladder is sliding along the ground away from the, so this foot is sliding like that, and that one is sliding down like that. Yeah? Okay? Remember, it's something like you keep a ladder, that ladder slides down, the leg goes down. If you're standing on it, your friend is already ringing the emergency. What's that, 911 is it? Or in India, in England, what is it, 999? I mean, in India, it is 999. You ring and somebody comes with an ambulance. Okay. Right. So since I don't know anything, let me call that as x, that as y. So that is dx by dt and that is dy by dt. Of course, it should be negative, so I'll assume that is positive and that is positive to avoid unnecessary negative signs. Okay. The rate at which the foot is sliding is 3 times the rate at which the top is sliding. So let's call this as u, that will be 3u. You're asked to find alpha. Yeah? Don't seem to have any link there. So remember, identify the variables. I have identified the variables. And write down any rates that are given. I know if this is moving at u, that will move, if this is moving at 3u, that moves at u. Very good. Then you're asked to find tan alpha. Tan alpha is x over y. You're asked to find the value of x over y. Yeah? Okay. Then for write down a relation that connects the unknowns, the only relation I have is x squared plus y squared equal to a squared. Pythagoras, the gentleman did it about 2,500 years ago, roughly. Yeah? And we're still using it and it's still valid today. Can you imagine how clever or how brilliant that must be? So, remember dx by dt, that means I must differentiate with respect to t. Remember, you never write dx by dt equal to. How do you differentiate x squared with respect to t? We have gone over implicit differentiation. X squared with respect to itself gives you 2x, and that gives you dx by dt. Y squared gives you 2y. Y itself gives you dy by dt. A squared is a constant, it gives you 0. But you know 2x times 3u plus 2y times u equal to 0. That's fine. So 6xu equal to minus 2yu. So what is x over y is minus 2u over 6u is minus 1/3, right? What is tan alpha? Minus 1/3. So we want alpha, so I'm not bothered about the negative sign. But tan alpha is 1/3. Alpha is tan inverse 1/3. Look, be clever. Don't try to find alpha in so many degrees. Then you're showing the examiner that you've gotten that when we're doing differentiation, it has to be radians. In the exam, under stress, confusion, you might forget it. So leave the answer as tan inverse 1/3. But if you want to give the exact answer, please use radians, not degrees. So let me turn it on. Let me change this into radians. How do I change it into radians? Menu, no. This calculator is a bit of a problem. I need to convert to radians. Shift menu, oh yes, to radians. Good. Now I want shift tan 1 divided by 3 is 0.322 radians. 3SF or 0.322 radians. If you write in degrees, you lose the final mark. So that's how, that was a question on rates of change. So I'll write the next question and then we will start. As I said, you will not know. You will just see me with the next frame. You will see the question written already, 1 or 2 questions. Okay. Well, welcome back. Maximum and minimum. So let's look at 5 part A. You have been given y equal to 2x cubed minus 3x squared minus 12x plus 5. You are asked to find maximum and minimum. Let me recollect all the steps we went through. Y is equal to 2x cubed minus 3x squared minus 12x plus 5. What's dy by dx? Is 6x squared minus 6x minus 12. Equate dy by dx to 0. Please understand, you must show your factorization, and when you expand your brackets, you should get the equation which you had. So if you want to keep this, then you have to do with 6x, but I will divide by 6. I get x squared minus x minus 2 is 0. So x minus 2 times x plus 1 is 0. You must show this and you must show this, whereas if you write this and write this, you lose the mark. So x equal to 2, x equal to minus 1. When x is 2, what is y? 2 cubed is 8, 8 2s are 16, 2 squared is 4, 4 3s are 12, 16 minus 12 minus 24 plus 5. 16 plus 5, 21. 4, 9. How am I going to do that? Yeah. Minus 36 plus 21 is minus 15. I hope I am correct. Or 4 minus 20 plus minus 15. X is minus 1. Minus 2 minus 5. Minus 2 minus 5 plus 12 plus 5. 10. So do d squared y by d. Remember, you must test for maximum minimum. Is 12x minus 6, x equal to 2 greater than 0, so minimum, x equal to minus 1 less than 0, therefore maximum. So 2 minus 15 is minimum, minus 110 is maximum. So whenever you have to find maximum, minimum, differentiate, equal to 0, showing your working, solve for x, find the corresponding value of y. If dy by dx is simple, find d squared by dx squared. Very good. Then don't equate d squared by dx squared to 0. Put the values of x you have. If it is positive, it is minimum. If it is negative, it is maximum. If it is 0, you must use gradients to find the stationary value. Okay. Now let's do part B. Again, I'll show you two methods in part B. First, let's do it. Then we will see. Y equal to sine squared x, cos squared x. Very good. So u equal to sine x the whole squared, v equal to cos x the whole squared. So du by dx equal to u is sine. Anything squared gives you 2 times the same thing. Sine gives you cos. dv by dx equal to anything squared gives you 2 times the same thing. Cos gives you minus sine. So dy by dx equal to u times dv by dx plus v times, sorry, that's a minus, times du by dx. As you can see, this is minus 2 sine cube x cos x plus 2 cos cube x sin x. So I can remove 2 cos x sin x as common factor. Okay. Then I am left with cos squared x minus sin squared x. So that is 2. Let's do it without using anything. So cos x equal to 0, sin x equal to 0, cos squared x is equal to sin squared x. So tan squared x equal to 1, tan x equal to plus 1, tan x equal to minus 1. For each of these, you need to find the value of x between 0 and pi. So here x is pi over 2. Here x is 0. Here x is pi over 4. X is 3 pi by 4. Now, do you realize to differentiate this further is going to take you ages. So, when x is pi over 2, y is 0. When x is 0, y is 0. When x is pi over 4, half times half is a quarter. And then the other one is a quarter. So you have pi over 2, 0, 0, 0, pi over 4 quarter, and then 3 pi over 4 quarter as stationary values. Stationary points. But then I have to find maximum and minimum. God bless. So I will take this. This is what I need. Okay. Easiest would be make a table. X dy by dx sketch. What are your stationary values? Start from the bottom. I got a 0. And then I got a pi over 4. Then I got a pi over 2. Then I got a 3 pi by 4. I'm only interested in checking. So take a value less than 0. Minus pi over 4. Pi over 6. Pi over 6. Pi over 3. 2 pi by 3. Sine of dy by dx. Cos is negative. Sine is positive. So that's going to be negative. Sine is negative. Cos is positive. So that's going to be negative. Cos of 30 is bigger than sine of 30, isn't it? Look, cos squared, for example, at minus pi over 6, that's root 3 over 2 whole squared, is 3 over 4 minus quarter. So that's positive, that is positive, that is negative, so that's negative. 0, if you take positive, that's positive, that's positive, that's positive, so that's positive. Oh, that is 0. And then here it is 0 at 60. Positive, positive, cos 60 is a quarter. Sine is is 3 over 4. So it's going to be negative. Yeah? And then 0. That is negative, that is positive. That is negative. So that's going to be positive. That is 0. So you can see here. Negative, 0, positive, 0, negative, 0, positive, 0, negative. So you know 0, 0 is minimum. Pi over 4 and quarter is maximum. Pi over 2 is minimum. 3 pi by 4 is maximum. Why I took this question was, look, it involved the whole of trigonometry. Yeah. Solving, equating each one to 0, then using gradients, right? But is there an easier way? Well, sir, you always do the long way and then you tell us there's an easier way. Yeah. If I just show you the easier way, look, the easier way works only in some cases. Shortcut, you know, Murphy's law, shortcut is the longest distance between 2 points. I know those are station points, right? Think for a moment. That's why I always tell you, God has given us brains. You know trigonometric identities. Can't you write it as sin x cos x the whole squared, which is half sin 2x the whole squared, equated to 0. Oh, not equated to 0. So it is quarter sin squared 2x. Okay, let me put it as quarter sin 2x the whole square. Now find dy by dx. Quarter is a constant. Anything gives you 2 sin 2x. And then sin 2x gives you 2 cos 2x. Look, this 2 is because of the power. This 2 is because of the 2x. Again, can we cancel this? So can we say sin 2x cos 2x? Your teachers have taught you trigonometry. That is a half sin 4x. Isn't life much easier now? So dy by dx equal to half sin 4x equated to 0. Sin 4x is 0. So PV is 0. SV is pi. So 4x equal to 2n pi plus PV plus 0, 2n pi plus pi. So x equal to n pi by 2 plus pi over 4. Put n equal to 0, that is 0, and that is pi over 4. Put n equal to 1, that's pi over 2, that is 3 pi by 4. Didn't you get all the 4 points? And you see the amount of work I have done. Then what you do is, you can do d squared v by dx squared is 2 cos 4x. When x is 0, it's positive, minimum. When x is pi over 4, it is negative, maximum. When x is pi over 2, positive, minimum. When x is 3 pi by 4, negative, maximum. You have all those answers. You didn't have to do the big graph and find out at negative pi over 6 and pi over 6 and pi over 3 and 2 pi by 3. So always try to think. Don't blindly do a question. Think, is it possible to make it simpler? May not always be. If you don't have a choice, like in the first question, we just had to do it. But here, if you know your trigonometry well, you should be able to do it much faster. That is what I tell you, the difference between an A and an A star. Yeah? Because look how much time you saved. So if you come across another question like this in the exam, at least you have more time to solve that particular question. Yeah? Good. I don't think I have time to do this question in this lesson. So I will do it in the next lesson. I will see you later. Okay? I'll leave this question on the board so you will see it when you come for the next lesson. Bye bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.